Hello. Today is actually a beautiful day outside. Blue skies and sunny and fairly warm. But I'm down here in the basement on Monday, March 30th around lunchtime to try and show you all the ins and outs of the LED lab for our intermediate physics lab course. You can read the lab. I won't go through all the theory, but basically if we can determine wavelengths of variety of LEDs and their activation voltages, from that information we can plot a graph and extract Planck's constant. That's basically what we want to do. All our LEDs are labeled with wavelengths. We're an experimental class, so we'd like to measure them as well, but we have them given to us. I'll tell you what those are. Next week I'll talk about, it turns out it's really hard to measure those wavelengths, and next week I'll spend a little time on that and tell you why it's hard and show you the best we can do. But after today, basically, you'll have the activation voltages and the wavelengths, and you can do the main analysis for this particular lab. Let me show you the equipment we have over at the next table. So there's this little card here, if I can focus it, that's got our LEDs on it. So these are LEDs over here. They'll light up. LEDs allow, if you put a voltage on them with high on this side and low on this side, you get a fair amount of current that flows after a while. But if you reverse bias them, you won't get much current flowing. So the symbol is this little arrow here, tells you which way the current flows. So the idea is to put a voltage across there and to measure the voltage when the light just starts to glow. Although that has a problem because of the sensitivity of our eye and background light and stuff like that. And we'll talk about, the lab talks about some of that stuff. The only other thing I want to point out is that all the diodes are tied together at one end and they go through a resistor. And that purpose of that resistor is to protect the diodes, because when they're forward biased, they're like very low resistors, so you can get very high currents, and that'll fry them. So the 100 ohm resistor is to limit the current. Now, everything happens with diodes around 1, 2, 3, 4 volts, somewhere in there. We have a signal generator that we're going to use, not a signal generator, but a DC voltage supply that we're going to use, and here it is, that goes from 0 to 20 volts. Let me explain this to you, I'll focus it a little better. This is a 5 volt battery, essentially, 5 volt DC battery. These two are independent, controllable voltage sources. The controls are over here. We're going to use channel A. This is channel A, the high and the low. It's like the terminals of a battery here. This knob controls the voltage, 0 to 20 volts. This knob is not as important. It sets a limit to the maximum current that this thing will output. We're just going to turn that up all the way. The problem is we have 0 to 20 volts controlled by this knob, but we want to have much more fine control. So the first thing we're going to do is build a voltage divider and only look at a piece of that 0 to 20 volts. And the way to do that is to use a rheostat. That's a rheostat. It's just a big long wire that's wound around a cylinder. It has left and right ends. There's a terminal here, and there's a terminal over here. And we're just going to put 0 to 20 volts across that. And then up top here is a tap, or a center tap. It's got a terminal as well, and it looks at the voltage from the midpoint of this, where this thing taps into. So let me set that up for you. So here's our 0 to 20 volts. And I want to put the low side down here. Can you see that? And the high side I'm going to put over here. And then if you look at what comes out of the center tap, the voltage at the center tap. So what I'm hooking up now is this voltmeter over here. And one side of it is connected to the low side of the voltage divider, and the other side is on the center tap. And you can see, first of all, as I turn this knob from 0 to 20, the voltage, instead of going from 0 to 20, the voltage across the center tap only goes up to 5. So if that's turned up all the way, if I move the center tap all the way to one end, then I'll get pretty much close to my 20 volts output. But I can limit the total output by moving the center tap in closer, and I do actually want to set it so it gives me about 5 volts max. So that's what I'm doing now. Yeah, that's pretty good. I think that's pretty good. So now that's the output right here that I'm going to put across my diode. But just so I make sure I don't fry the diode, I'm going to turn my voltage all the way down. Okay, great. So here's the high side. It's the high side. I choose the red diode to start with. Here's the low side. Except I want to monitor current. So I also have here an ammeter. Looks like the voltmeter because it's actually a multimeter. So there's my ammeter, and if you remember how to do an ammeter, I need to open the circuit and splice in my ammeter in the middle of the circuit. All right, so now my circuit, basically, my power supply is really the center tap. So here's my positive signal. Goes to the ammeter. Out of the ammeter, it goes to a diode. Goes through the diode, through the 100 ohm resistor, and out, and then it comes back to the center tap. And as I control this knob from 0 to 20 volts, I end up putting 0 to 40 volts across the diode. Great. Let me turn the ammeter on. I've already I got the voltmeter on, but I want to hook the voltmeter up now. So the last thing I have to do is hook the voltmeter up to monitor what's going on across the diode. So now I have my two terminals, my voltmeter, this are the two terminals from the voltmeter, are now hooked across the diode. Not across the resistor, just across the diode, right? So that's what this guy is here. So now, my voltmeter reads the voltage across the diode, my ammeter reads the current through the diode, and by adjusting this knob in the back here, I can adjust those things. So let's see if I can set this all up and we can see everything that's going on here. All we can't see is the diodes. Oh, I'm not doing so well, am I? There we go, maybe that's better. Okay, great. So now I'm going to start turning the voltage knob up. And you can see I start get a little bit of voltage, but I still have no current. The voltage keeps going up. It's going backwards. Why is it going backwards? Yeah. Yeah, I just have these backwards in the voltmeter. Okay, so the point is, as I slowly crank this up, I get voltage, but I'm not getting any current, not getting any current, not getting any current. And all of a sudden, at some particular voltage, I start getting current. Where the current starts basically is the activation voltage. So what I've done is I've taken data, basically voltage versus current data for each diode from about very low voltage, 0.5 volts, up to about, I don't know, 3 volts or so. Certainly I didn't want to exceed the 20 milliamps. Never want to go above 20 milliamps. By the way, I guess you can see the diode glowing right here. You see the diode come on. It's really what you want to find out is the voltage when it first comes on. Although the curve is not, it's not abrupt, it's kind of smooth. So that's part of what you have to do is figure out where you want to call it on to figure out what this voltage is. So that's basically how we take the data for this lab, and I'm sorry it's so messy, but it's a little bit complicated to do by myself. Anyway, I think I'll sign off now. You email me if you have questions.